Hello, welcome to Mat-073. My name is Rob Reynolds. Today we're going to be looking at operations with real numbers, looking at how to add, subtract, multiply, and divide real numbers, and looking at some definitions of opposite. There's a lot of definitions. You can read through these PowerPoints, moving positively to the right, negatively to the left, but zero stays right where it's at. Some professors use number lines to try to denote the movement. If I start at 6 on the number line, and then this says move to the left 8 units, I'm heading this way 8 units, that will put me at -2. So you can't see on my number line here, but so I'm starting at 6, I move 8 units to the left, and I end up at -2. I would prefer not using the number line. If you kind of memorize some rules, I think it's kind of faster. The rules are, if signs are different, we subtract. So 8 minus 6 is 2, and then we keep the sign of the larger, and then the larger here would be the absolute value larger number is 8. Well, I'll talk about that for a second. Actually, 6 is larger than -8 because it's further to the right on the number line. So when I ask you to keep the sign of the larger, I'm asking you to keep the sign of the larger absolute number, the one that's further away from 0. So -8 is the larger number, so we're going to keep the negative. So again, if signs are different, we subtract, and then the reason why the answer is negative is because 8 is larger than 6, or the absolute value of -8, which is 8, is larger than the absolute value of 6. So again, signs are different, so we're going to subtract. 7 minus 3 is 4, and I'm going to keep the sign of the larger. This time the larger is positive, so I'll keep a positive 4. There's the solution. Here, signs are alike. So this time, instead of subtracting, I would add. So 2 plus 5 is 7. And if signs are alike, this time I'm going to keep the common sign. Since they're both negative, I will keep the negative. If they both would have been positive, I would keep the positive. There's the solution. So again, if signs are alike, I'd like for you to remember to add. If signs are different, we're going to subtract. Here we go. If signs are different, then subtract. So if you could pick that up, that's faster, I think, than the number line. The property of 0 just says if you add 0 to any number, for example, 5 plus 0, you'll get 5 back. Without using a number line, here you go. What are signs? Well, they're alike, so we're going to add. 13 and 8 is 21. And then all you have to do is decide if it's positive or negative. And well, again, add and alike. So signs are alike, we keep the common sign. If signs are different, we keep the sign of the larger. So here's some practice. 48, well actually a -48 and a +31 signs are different, so subtract. So that's how you can remember it. Different starts with the D, and I would go differ by, which is the same thing as subtract. So different, find the difference of something means subtract. So if signs are different, you find the difference, or subtract. If signs are alike, then we add. So the D's kind of go together, and the A's go together. So if the signs are different, we subtract. I know that starts with an S, but that means that's a difference. And if signs are alike, then we're going to add. So back to our examples. Signs are different, and 48 take away 31 is 17, and we're going to keep the sign of the larger, which is the 48, so I'll keep it negative. If the numbers are the same and they're just the opposite, that will give me a 0, and 0 plus any number is itself, so this is back to -5/9. And this is kind of interesting. 24 is the common denominator, so we're going to change. We can't add fractions unless we find common denominators, so we have to ask ourselves, what does 3 and 8 both go into? And so they're both going into 24, so I would take 3 times 8, and then multiply this by 8. 2 times 8 is the 16, and you keep the negative sign up front. And you repeat this process for the 8. So you're asking 8 times what number? 8 times what number gives you the 24? So you're going to multiply by 3. And if you do that to the denominator, you have to do that to the numerator. And 5 times 3 is 15. So then we've got a -16 and a +15. Signs are different, so I'm going to subtract. That's 1, and keep the sign of the larger. So I would say this answer would be negative 1/24. And it looks like the author here agrees. Two numbers whose sums or zeros are called opposites. So we're going to talk a little bit about opposites. The opposite of 8.6 is negative 8.6. 0 does not have an opposite, and the opposite of a negative number is positive 7/9. There are some solutions. This is negative, but it's also pronounced the opposite of x. So if I were to ask for find the opposite of x, well, the opposite of x would be negative 23. This is interesting because it's the opposite of a negative, which is positive. So this is actually written the opposite of negative x would equal the opposite of negative 23, which is back to positive 23. So it looks like they're asking you to find two things. Find the opposite of x. Well, the opposite of 23 is negative 23. But then find, did you know that the opposite of negative x is the same thing as just saying find x? Well, they gave me what x is. X is 23, so the answer is just 23. Let's do it again. What's the opposite of negative 5? Well, the opposite of negative 5 would be the opposite of negative 5. Two negatives is a positive 5. Then it says, what's the opposite of a negative? Well, the opposite of a negative is the same number. So the opposite of a negative x is the same thing as what x is, and it gave me that x was negative 5. A little bit confusing, but again, the author wrote this out for you so you can look at this at your leisure. Feel free to pause the video. Again, this is saying the opposites will always equal 0. It doesn't matter the order that you put them in. So again, it says change the sign or find the opposite. The opposite of negative 3 is 3. There's no opposite of 0. And the opposite of 14 is negative 14. The absolute value, we talked a little bit about it in our earlier lesson, is actually the distance from 0. And I gave you the definition in review section R1, the previous lesson of this. And it was kind of confusing because we always think that the absolute value is going to be a positive number, and this looks confusing because it looks like I'm telling you that the absolute value is a negative, but it's not. We're going to read this as the opposite. So if I were to ask for the absolute value of 5, it's still 5. If I ask for the absolute value of negative 5, it's still exactly what you think it is. It's still 5. The answers are always positive. You're right. But what about the definition? Well, the definition says it's the opposite of my a term, and up here, a equaled negative 5. So we actually took the opposite of negative 5 to end up with this 5. So that's, again, according to the definition. The absolute value is sometimes a for those values that are positive, but it's the opposite of a negative number if a is negative. This is just going through some definitions. You can add b to both sides and end up with a is equal to b plus c. So you can do anything you want to an equation as long as you do it to both sides. This is the same thing as adding the opposite. Instead of subtracting b, you could add the opposite of b. I do not prefer double notation. I would clean it up. I would never write a plus negative b or a plus minus b. I just don't like the notation. I would simplify that to be a minus b. Don't have double negatives. So I do not like this pink term. I would just say 3 minus 5, and I would recognize this as a negative 5. So if I ask our signs are alike or different, don't tell me that they're alike because this is a positive 3 minus a positive 5. Instead, I want you to recognize that this minus is really the same thing as a negative because you can add the opposite. So if I ask for you to subtract 3 minus 5, I would say that's a negative 5 because there's a minus sign there, which is the same as a negative. So signs are different. We subtract. 5 minus 3 is 2. All you have to do is keep the sign of the larger. Well, the larger is 5, and its sign is negative. So I would say this answer is negative 2. Let's do it again. Instead of subtracting a negative 3, we can add the opposite. So this is the same thing as 7 plus 3. One professor showed me that this neat little trick. Whenever you have these two negatives, doesn't that kind of make a little plus sign in here? So you can see 7 plus 3 is 10. So that's the nicest way. Here, signs are alike. They're both negatives, so we're going to add. Remember, alike means add. I'd grab a calculator, do 19.4 plus 5.6. I believe that's around 25. All you have to do is determine if that's positive or negative. Well, if signs are alike, you add and keep the common sign. and both signs are negative. So you're 19.4 in the hole to the left, but you're going to the left even more, 5.6. That puts you at negative 25. Remember, you can't add fractions if I don't have a common denominator. So not only would I go ahead and try to take care of these signs in here by adding the opposite, there's that plus sign again, I'd also try to rewrite this and get common denominators. So I'm going to look for multiples of 3 and 5, that a common multiple of 3 and 5, which is 15, and I need to multiply this 3 by 5 in order to get to this 15. So I multiply this by 5 and bring over a negative 20. And I found the negative 20 from right here, which is the negative 4 times 5. That's the negative 20. I'm going to repeat this process by multiplying by what's lacking for the 5. So the 5 goes into the 15 3 times. So if I multiply the bottom here by 3, multiply the top by 3, and this says bring over a negative 6. We haven't really talked about how to multiply, but it sign, well, be careful. This is really a plus sign though. So this was a positive 2, and this was a positive 3. Excuse me, this is a positive 6. So now when I'm looking at this, this is a negative, this is a positive. Signs are different. I said subtract, keep the sign of the larger. Well, 20 is larger than 6, so that's a negative. And I would wind up with negative 14, 15. So let's see if the author agrees with me. Well, good job. So again, they changed that double negative to a positive. I would encourage you to do that just like we did back in exercise 20. So again, what I'm trying to teach you today is if signs are alike, then add, keep the common sign, and the answer is going to be positive. If signs are different, you subtract. So for multiplication, little bit rules change just a little bit. If we're multiplying, if signs here's the rules for multiplication. Oh, there it is. Rules for multiplication. If signs are alike, the answer is going to be, so a negative times a negative is a positive. If signs are different, it doesn't matter if it's negative times positive or positive times negative, it will always be negative. So rules for multiplication. So we're switching gears from addition, subtraction to multiplication. And by the way, those rules work for division as well. So 6 times 7 is 42. Signs are different, so it's a negative. I'd grab a calculator and multiply that out. The important thing is you can tell that this is going to be a negative answer because signs are different. Evidently, 1.2 times 4.5 on a calculator is 5.4. And you can use a calculator on your test, so feel free to use it on your homework. Two negative numbers, to multiply two negative numbers, they're alike, so you're going to hit a positive. So again, just treat this like 3 times 5. 3 times 5 is 15. It's just here, instead of keeping the common sign like we were doing before when we add and subtract, this time the rules for multiplication say if signs are alike, we're going to end up with a positive answer. And there's the author's answer, 15. So this time, instead of dividing, instead of saying A divided by B, we could write it as this, A divided by B. Just make sure that you don't divide by 0, so B can't be 0. So if you have an equation, A equals B times C, and you divide both sides by B, notice that this will cancel out. So here comes it's an equation. You could do whatever you want. So here comes a new equation. A divided by B is C. So all sorts of ways to manipulate equations. 10 divided by negative 2 is negative 5. The reason why is because instead of dividing by, well, I would say if signs are different, the answer is going to be negative. I'm not going to get into how they're going about here. So here, signs are different, so the answer is going to be negative, and 10 divided by 5 is 2. Here, signs are alike. The answer is going to be positive, and I can't really do much with 10/3. Maybe I could change that to a decimal, and that's what the author does. But he says, or just leave it 10, positive 10/3. So to multiply or divide absolute values, if the signs are the same, then the answers are positive. If the signs are different, the answers are negative. We cannot divide by a non-zero number. We can't divide by 0. So the rule that I have is if 0 is under, it's underdefined. And here's the symbol for undefined. This just means no solution is possible. On your calculator, if you take your calculator and do 5 divided by 0, your calculator will give you a strange error message. So here's that can't do it. Now be careful, 0 divided by 7 is defined as 0. That's a real number. Undefined is different. So if you're used to writing this, this is not a 0. And I know some students write 0 with a slash through it. But in this math class, this stands for the empty set, no solution. So be careful, because if I see that, I'll assume that you mean no solution opposed to 0. This one you simplify. Well, x minus x is 0, so 4 divided by 0 is also the empty set. And it looks like, good, not defined, not defined. So instead of using 0 with a slash through it, they're actually writing out the words not defined. The reciprocal, instead of dividing by a fraction, you can multiply by the reciprocal. That's a helpful tool. So first of all, we'll talk about reciprocal. It just means flip it. So the reciprocal of 4/5 is 5/4. The reciprocal of 8 over 1 is 1/8. And there is a 1 down here, whether you like it or not, because 8 is the same thing as 8 divided by 1. And the reciprocal of a negative is not positive. The reciprocal of a negative remains negative. So you don't change the sign. You just flip the fraction. So again, a divided by b could be written as a divided by b, but it's the same thing as a times 1 over b. That's an important rule as we move through math. So there's some more examples. Here's an example. Instead of dividing by negative 4/9, I would flip the blue. Don't ever flip the first fraction. So I'd rewrite this as 2/3. Instead of dividing by a fraction, we can multiply by the reciprocal. So I would have negative 9/4. Then I would see if I can simplify. I can reduce 9 divided by 3. Actually, that's a negative 9 divided by 3 is negative 3, and the 2 and the 4 cancel, reduce to a 2. Well, 2 goes into 2 once, 2 goes into 4 twice, so I think this answer is going to end up to be negative 3/2. Let's try to do this one more time. Instead of dividing by a fraction, which 3 over 1 is a fraction, I'm going to rewrite this, and negative 5 over 7 times 1/3. This time I can't cross cancel anything, so I'll just multiply straight across. So negative 5 times 1 is negative 5, and 7 times 3 is 21. So we'll see if the author agrees. Yep, negative 5/21. Negative divided by negative is still a positive. That rule stays the same, and our next lesson will be exponential notation and order of operations. Hope that was helpful. Email me with any questions.